Welcome, everyone. I'm excited to kick off our presentation today on object model elements. Today's focus is on key minor components overview. Since this is our first slide, I want to warmly welcome you all and introduce the topic with enthusiasm. We'll be exploring the fundamental elements that make up object models and their small but important components. In this session, you can expect a clear overview of these key parts and how they fit together. Let's get started. Welcome to this part of the presentation. Here, we're going to explore some of the essential minor elements of object models. Specifically, we'll focus on three key areas: typing, concurrency, and persistence. These might seem like small pieces, but understanding them is crucial for designing systems that are both robust and efficient. As we go through, I'll explain what each of these components means, their roles within the object model, and how they impact the behavior of the system as a whole. We'll also look at how they influence system performance. By the end, you'll see how these elements, though minor on their own, are vital for building reliable and high-performing applications. So, let's dive into each of these aspects and see how they fit into the bigger picture of object-oriented design. All right, let's talk about typing in object models. When we're working with object models, one of the key aspects is defining the types of data each object will contain. This helps ensure consistency and clarity throughout our design. For example, specifying whether a property is a string, an integer, or a date allows us to catch errors early and makes our models more reliable. Typing also plays a crucial role in enabling tools to assist us, like auto-completion and validation, which can boost our productivity. As we develop more complex systems, clear typing becomes even more important because it helps us understand how different objects interact. Overall, incorporating proper typing into our object models is fundamental for creating robust, maintainable, and understandable systems. Let's talk about type safety and type checking. Type safety is really about preventing those pesky type errors during program execution, which helps make our programs more reliable. When we say type checking, we're referring to the process of verifying that the values we're working with actually match the expected types. This can happen either at compile time, before the program runs, or at runtime, while the program is executing. Both approaches serve to catch potential issues early, reducing bugs and ensuring our model remains consistent. This is especially important in object-oriented systems, where maintaining integrity and dependability is key. So, in essence, these mechanisms are vital tools that help us build safer, more dependable software. Let's talk about the role of typing in maintaining model integrity. Typing is all about ensuring data correctness by clearly defining what types of values an object can hold. This is crucial because it helps us prevent invalid operations before they even happen. Strong typing acts like a safeguard, catching errors early and protecting the integrity of our models. This foundation is essential for reliable software development because it reduces runtime failures and makes our code much easier to maintain. When our data types are clearly defined and enforced, everything becomes more predictable and robust, which ultimately supports the overall quality of our systems. Let's dive into the concepts of concurrency and persistence, which are crucial for building reliable and efficient systems. Concurrency refers to the ability of our system to handle multiple tasks simultaneously, which is essential for improving performance and responsiveness. When we talk about concurrency, we're really talking about managing multiple processes or threads that can run at the same time without interfering with each other. Persistence, on the other hand, is about ensuring that data remains available even after the system is shut down or restarted. Think of it as saving your work so it's not lost, whether that's through databases, file storage, or other means. Connecting these two ideas, effective concurrency controls are vital when working with persistent data. Without proper management, concurrent access to data can lead to conflicts or corruption. So, understanding how to coordinate concurrent operations while maintaining data integrity is fundamental. Overall, mastering concurrency and persistence allows us to create systems that are both fast and dependable, capable of handling multiple users and large amounts of data seamlessly. This synergy is at the heart of scalable, real-world applications. Let's dive into concurrency control mechanisms. Essentially, this is about managing how multiple processes or threads access shared objects at the same time. The goal here is to prevent conflicts that could lead to data corruption or inconsistencies. To do this effectively, we use several techniques. One common approach is locking, where a process locks an object while it's being used to prevent others from interfering. Then there's optimistic concurrency, which assumes conflicts are rare and checks for conflicts only at the end, allowing for more overlap and efficiency. Transactional memory is another innovative technique that simplifies concurrent programming by executing blocks of code as transactions, ensuring they either complete entirely or not at all. By implementing these mechanisms properly, we support multi-threaded applications, making them more reliable and robust, especially in environments where multiple processes work simultaneously. This is a key part of ensuring our systems remain consistent, efficient, and secure as we scale and handle more complex tasks. Let's dive into persistence strategies and storage models. Essentially, persistence is about saving the state of objects so that they can survive beyond the lifetime of a program's execution. This is crucial because we often need to store data in a way that it can be retrieved later, even after the application has closed. Now, to achieve this, we typically use databases, file storage, or object relational mappers. Each of these methods has its own advantages and best use cases. For example, serialization is a common strategy where objects are converted into a format that can be easily stored and reconstructed later. On the other hand, database mapping involves linking objects directly to database tables, which is especially useful for applications that require complex queries and relationships. The key takeaway here is that selecting the right persistence strategy depends on your application's specific needs, whether it's data durability, speed, or accessibility. Effective persistence isn't just about saving data. It's about ensuring that data remains reliable and accessible over time, which is fundamental to building robust, long-lasting applications. Throughout this presentation, we've emphasized how important data management is to software development. Persistence, strategies, and storage models are the backbone of maintaining data integrity and consistency in any system. So, in conclusion, understanding the minor elements like typing, concurrency, and persistence really is essential for building robust and scalable object models. These components might seem small, but they play a huge role in maintaining data integrity, especially when multiple users are involved. They also help ensure that data remains available over the long term, which is critical for system reliability. By incorporating best practices in these areas, we can significantly strengthen our overall system design and improve operational efficiency. Ultimately, paying attention to these details helps us create systems that are not only effective today, but also adaptable and resilient for the future. Thank you so much for your time and attention today. I really appreciate it. This is the final slide, and I just want to express my gratitude for your engagement throughout the presentation. Remember, the key points we've discussed highlight the importance of the strategies and insights shared. I hope you found the information valuable and that it inspires you to take action or explore further. Connecting everything back to our overall theme, it's clear that with the right approach, we can achieve meaningful results. Once again, thank you for your participation and interest. I look forward to seeing how you apply these ideas in your own projects. Thanks a lot, and have a great day.